Welcome to the CISSP Cyber Training Podcast, where we provide you the training and tools you need to pass the CISSP exam the first time. Hi, my name is Sean Gerber, and I'm your host for this action-packed, informative podcast. Join me each week as I provide the information you need to pass the CISSP exam and grow your cybersecurity knowledge. All right, let's get started. Hey all, Sean Gerber with CISSP Cyber Training, and hope you all are having a beautifully blessed day today. Today is what? Yeah, it's CISSP Question Thursday, and we are going to be going over a multitude of questions, actually 15 to be exact, questions that are related to Domain 8.5 of the CISSP. But before we do, I had a quick article I wanted to bring to your attention. I thought was very telling and very interesting, especially for you security folks that really want to get into AI and try to understand a little bit around that. This is from Computer World, and this is OpenAI CEO was mentioned that some of his people have been trying to be recruited. So Sam Altman, obviously the CEO of OpenAI, is said that Meta, obviously Facebook, tried to lure OpenAI employees with, air quotes, billion-dollar salaries. So for you all that are aspiring to be AI aficionados, you may want to consider being an AI aficionado because you're talking some serious cash. I mean, holy cow. I mean, that blows my mind. But basically, this article from Computer World came out and said that Meta tried to poach employees from AI and Google DeepMinds by giving them huge compensation packages. And these compensation packages were like $100 million sign-on bonus with more than that in annual compensation. So you're talking freaky crazy money for being the AI god and goddesses that they need to have within their organization. Now, obviously, this isn't going to be the intern that just came out of the local college at your local JCO, but it is a great understanding of what do they value when it comes to understanding AI, and they will throw a lot of money at it. Sam Altman basically said that a lot of these attempts have failed largely. That doesn't mean they haven't all failed. But the point I'm trying to make in all of this is it's pretty crazy on what you may need for being, what you may be able to get from a compensation package related to AI. So as we talk about security, one of the things I wanted to just quickly touch on is what does it take to be an AI kind of person? Now, obviously, we're talking cybersecurity in this space. So realistically, I'm just going to focus on that aspect of it. So being a CISSP, obviously you have to have the experience to get some level of experience, or you have to have the experience to be able to get the test. But at the end of the day, you're going to have a lot of knowledge around security to really be effective in any sort of AI cybersecurity role. But one of the other aspects that I think is really important, and I was just kind of curious what out there in the world, what the world thinks of it, is understanding, obviously, AI and machine learning expertise is a big part of this. So having a good knowledge around AI and machine learning and how it works would be a very valuable tool. And if you have some of that experience and you really enjoy security, then I would highly recommend that you focus pretty strongly on hitching onto that AI bus and don't let go. But you're really going to need to have some strong cybersecurity knowledge as well. And that's some of the big articles that kind of popped up as I was looking for this, is you can't just be, I'm going to go pass the test and move on. I had one of my students that I have my mentoring that I provide to my students. And one of my students had mentioned to me that he likes the podcast because the fact that he can gain knowledge beyond just what the test will give him. And that's what actually one of the huge benefits of this podcast is it's going to provide you knowledge from industry leaders. And I mean, the information you're getting is I'm working with all kinds of very large organizations down to actually some very small nonprofits. So you're getting a really good broad brush of security. And I'm not telling you that to basically say because, oh, we're an awesome podcast. No, I mean, we are awesome. There's no doubt about that. But the thing is I wanted to bring up is the ultimate goal of this is to help you get the knowledge you need to be, one, very successful in your career, two, well, first off, pass the CISSP. Then second is to be able to be very successful in your career and provide really good insight and knowledge to the decision makers within your organization. And just trying to help you out there. And this is a really good example around AI in that if you take this information, you build upon it, and then you start looking for different opportunities within, especially the AI space, you're going to stumble across things. And one thing you may want to also think about as a security professional is the fact that guess what? Very few people have it figured out. And I would be willing to guess that probably 99.9% of the people out there really don't have it figured out. And anybody who tells you they do, they're lying to you, because most people don't. And we stumble into these things as we go forward. And so it's an important part of your cybersecurity career is that you take this knowledge, you grow on it, you be a consistent and constant learner, and that will take you to places that you may have never even imagined you would be to. So again, that's a big nugget right there for you all. If you are listening to this and you want to figure out your career, that is an option for you to really consider, because especially in these burgeoning areas such as AI, but there's many, many more. I would come back to manufacturing. People don't think it's very sexy at times, but I'll tell you right now, there's money to be made there, especially as it relates to critical infrastructure. They don't have high margins, but if you bring to the table, and especially if they've been pwned at any point in time, you bring knowledge to the table, you can command a very strong salary out of that. So again, some great tidbits, some great nuggets for you to look at from a career standpoint. Great article. Again, it's very quick read. It's about 2.5 minutes. But what it comes down to is that AI is here to stay. And I would recommend that if you don't have some knowledge in this right now, start getting some basic knowledge so that you can at least talk logically to folks when they start asking you questions. Especially as I deal with Next Peak, we actually have a really strong AI framework, a risk framework that we've built for companies. And it's honestly, I'm really impressed with what we've created there. And it's going to be something that's going to be very helpful and very useful for many companies, especially as you're deploying AI within the overall ecosystem, big $10 word, within your company. And so again, AI is awesome. We'll see where it goes from here. All right, let's move on to the questions of the day. Okay, as you know, these questions are all on CISSP Cyber Training. They're all available to you. You just go out and you purchase one of the packages I have, and you will get them. If you don't want to do that, that's fine as well. You can get these through the podcast, and then I do post some of these on my blog from time to time. So all of this stuff will be available to you in some form or fashion. It just may take a little while for you to see it if you're going down the free version. But it's all available to you. So again, CISSP Cyber Training, you can go check out what I have, and you can get access to all of these questions. Okay, so question number 1. Again, these are over 8.5 of CISSP, and we're going to get into question 1. It's the development team is refactoring a legacy application that uses XML for data exchanging. To mitigate a risk of an XXE, XML, basically external entity attacks, which secure coding practice is most critical to implement? So you got XML, and there's basically the risk of an XXE, which is an XML external entity attack. What is the best secure coding practice that is most critical for you to implement? A, disabling DTDs, that's Delta Tango Delta, that's basically called a document type declaration, or external entity processing in the XML parser configuration. B, implementing a client-side input validation on all XML fields. C, utilizing web application firewalls to filter out XML traffic. D, encoding all special characters within XML content. Okay, so this question, you may go, I don't know anything about this. How can I narrow it down? So if you just read this question, you'll know that you're not going to deal with XML at the WAF. You're just not going to deal with it. And then encoding special characters within XML content, that's just not even feasible for something you're trying to accomplish on this, especially when you're dealing with the most critical thing to do, most critical thing to implement. So you really narrow it down to DTDs and then implementing client-side input validations on all XML fields, and which even that would be a challenge, right? So this XXE specifically exploits vulnerabilities in how the XML parser handles external entities. These are called DTDs. And this is therefore, by disabling these or restricting external entity processing, you then have a situation where it helps prevent the parser from processing external entity references. Now, the point it comes down to is if you don't know and you see external entity processing and you don't see it anywhere else and it's in the question, maybe, again, if you don't know, maybe grab onto that and make that as your best guess. That won't always be the case, but ideally you want to kind of narrow it down, one to the first two that you feel relatively confident with, and then look for little tells that are inside the question that may help you with the actual answer. So that one's a tough one, no question about it. Question 2, a microservices architecture uses RESTful APIs to communicate between services. Okay, so if you dealt with microservices, that definitely happens. An attacker discovers that by rapidly sending requests to a user's registration endpoint with a unique long strings for username and password fields, they can cause a database connection to pool to exhaust, leading it from a denial of service. So basically, it barfs all over itself. It fails, right? Which API security control would have the best prevented this type of attack? Okay, so again, you're DDoSing a situation and they're sending information. In this case, it was username, not actually password, that causes the database connection to pool to exhaust. Okay, so what's going to happen? You're creating a denial of service. A, API gateway with manual TLS. B, input validation limiting string length and character sets for username. C, output encoding on the database response to the application. Or D, centralized logging and monitoring for API calls. So the question is best prevent this type of attack. So you're not going to be able to prevent it through adding TLS, right? The API connection is going to be there. Output encoding of the database response to the application, not so much is really going to help you a whole lot on that. And then logging, yeah, you're going to know something's happening, but that's about the extent of it. But the biggest thing here is what? Long strings for usernames. So you want to have input validation limiting the string length and the character sets for the username. Now, an easy way to trick you up on this would be the character sets for the password. Well, if there's no password in the actual question, you may glob onto that. So just kind of keep that in mind. Question 3. During a security audit, it is discovered that an application handles user-uploaded profile pictures by storing them in their original file names on a web-accessible server. Not good. Without proper sanitization. An attacker successfully uploads a file named maliciousscript.php that executes on the server. This is primarily an example of what type of vulnerability. Again, so what's happening is it allows uploads of pretty much anything you want. And in this case here, maliciousscript.php was uploaded. So what type of vulnerability is it dealing with? A, insecure direct object references. B, cross-site scripting. C, unrestricted upload of dangerous file types. Or D, server-side request forgery. And the answer is C, unrestricted upload of dangerous file types, right? So we got a dangerous file type known as maliciousscript.php. So that's be dangerous. You don't want that to be uploaded. That would be bad. So having the ability to understand, one, it's accessible by the web, and then having the ability to scrape that and understanding that you don't want someone to upload a PHP file that has got, say, malicious script, that would be bad. So you're trying to, it's trying to help you think and walk through this overall process. If you have to narrow it down, that would be one to narrow it down too. Question 4, a critical banking application performs credit card or credit score checks by directly concentrating a user's provided account number into a SQL query. To securely mitigate the risk of SQL injection, which secure coding practice is the most robust and recommended approach? So again, you've got credit score checks, you've got account numbers put into SQL, and you're worried about a SQL injection. Okay, so the answers: A, implementing a strong web application firewall in front of the application. B, escaping all single quotes in the user-provided input string. B, applying the principle of least privilege to the database user account. Or D, using prepared statements with parameterized queries. Okay, so that is a lot of stuff. Big $10. Actually, that's probably like a $20 word. So again, a WAF can help to some level, but again, it's not the best approach. And it's common, but it's really an insufficient defense against this type of activity. Prepared statements with parameterized queries are the most robust. It's the best recommended method of preventing a SQL injection. And they do this by they separate the SQL code from the user-provided data, ensuring that the input that is coming in is not executable code. So again, prepared statements with parameterized queries. And so again, it's understandable that you don't want to have some input that you put in and it's got some sort of randomized code that's in there. It will reject that in this situation. Question 5, a software development team adopts a security as code methodology. Which of the following is most likely to be an increased risk or challenge in this new paradigm compared to the traditional security management plan? Okay, again, software development teams look at security as code methodology. How is this different than the normal plan? So A, difficulty in automating security policy enforcement. B, increased potential for human error in manual security configurations. C, introduction of version control and configuration drift issues for security policies. And then D, reduced visibility into the security posture of the infrastructure. Again, so the question is asking, which of the following is most likely to be an increased risk or challenge in this new paradigm as security as code, compared to what they used to basically do in the past? And the answer is C, introduction of version control and configuration drift issues for security policies. So what is security as code, right? It's a component of software-defined security, but basically it helps you by managing security policy, configurations, controls. All of that is done by code. If you're dealing with any sort of things online or in the cloud, that is how it's all done. It's all done through code. This offers a lot of benefits for automation, consistency, repeatability. However, it does reduce the challenges or increases challenges of managing these of the code specifically. One is version control. Two is configuration drift. That ensures basically that the deployed infrastructures accurately, my gosh, that's late tonight, sorry, reflects the policy as code and doesn't deviate. Testing, obviously, that's another thing, is that you don't have the chance to always do that, and then increase potential for human error in manual configurations. Those are all challenges that are part of this. So in introduction of version control and configuration drift issues, this could be something you'd have to potentially deal with. Question 6. An API endpoint allows for users to retrieve their own account details using an account ID parameter of /API version 1 users account ID 123. Okay. Basically, just what would that API look like if you enter that in that parameter in? The attacker discovers they can change the account ID to 456 and access somebody else's account. Right? So you're 123, but if I put in 456, I now can access somebody else. This is an example of what? A, cross-site scripting, cross-site request forgery. B, broken authentication. C, server-side request forgery. Or D, insecure direct object reference, or otherwise known as IDOR. Okay, so which one is it? You're basically transposing 123 into 456, and now from being mine was 123, my account, my ID, and now I can get into bills at 456. So what is that? That is D, insecure direct object reference. Okay, this occurs when the application exposes a direct reference to an internal implementation object, such as your account. And that would be Sean is 123, but Bill or Dave or Fred is 456. It does not properly verify the user requesting the object is authorized to access it. So if you've ever tried that before, you can get into your web browser and you can start making changes to it and see what it does. Does it give you back information or does it barf on itself? That is something you'll have to work through. But this would be a situation where you'd have insecure direct object reference, is where it's giving you information on somebody else without authenticating. Question 7. When developing secure APIs, which standard or framework is primarily focused on enabling secure, delegated authorization for web and mobile applications? This allows for limited access to user accounts on a HTTPS or just HTTP device. So again, when developing secure APIs, which standard or framework is primarily focused on enabling secure, delegated authorization for web and mobile applications? This allows for limited access to user accounts on a HTTP service. Okay, A, OAuth 2.0. B, SAML. C, OpenID Connect. Or D, WS Security. Okay, we had this on a couple podcasts ago. We kind of talked about this a little bit. And the answer is A, OAuth 2.0. This we've talked about on CISSP cyber training multiple times. But when OAuth 2.0 is an industry standard protocol for delegated authorization. It allows users to grant third-party applications limited access to resources on another service, right? So if you're using Google, it allows that kind of activity. And it does this without sharing your credentials directly, right? SAML, which we talked about as well, is primarily for federated authentication using SSO. And then you got OpenID is an authentication layer built on top of OAuth 2.0. And then you're dealing with what WS Security deals with SOAP. So bottom line is it is A, OAuth 2.0. Question 8. An application input validation logic for user comment field correctly filters out common script tags such as bracket script. However, a penetration tester successfully injects malicious code using encoded HTML entry of, script with a lot of other stuff in there. Which secure coding practice was likely overlooked? A. Whitelist input validation. B. Proper output encoding. C. Context-aware output encoding. Or D. Implemented content security policies. So bottom line comes down to is that the scenario highlights in this case weaknesses in your blacklist input validation, right? So you're trying to block known bad characters. So when you're dealing with this, the whitelist input validation is a more secure practice. So this is what was possibly overlooked in this case here. So it explicitly defines and allows only what should be good and safe, such as alphanumeric numbers, a set of HTML tags, whatever that might be. That is your whitelist input validation. Question 9. A potential race condition vulnerability is identified in an application where two concurrent threads attempt to update the same customer balance without proper synchronization. Which secure coding standard is most directly violated? Again, what's a potential race condition? Things running away. Vulnerability is identified in an application where two concurrent threads attempt to update the same customer balance without proper synchronization. Which secure coding standard is most directly violated? A. Input validation standards. B. Concurrency control standards. C. Secure error handling standards. Or D. Output encoding standards. So if you don't really know, you're like, I don't know. Could be input validation. Yeah, I would probably head to that. Let's do that, right? Well, that would be wrong. So the answer is B. Concurrency control statements. And concurrency control statements, you would want to kind of look at concurrent threads, if you don't know, up in the question. That might give you a hint, might kind of guide you down this path. But a race condition will typically arise when you have concurrent program environments are trying the timing. They're trying to interleave operations with different threads. And you see this happen with your clouds and your Word that's connecting with multiple people. They're all accessing at the same time. When you have people concurrently getting access to it, it can potentially has issues. And so therefore, this is what this vulnerability is talking about, is that it allows for a race condition. That they're getting ahead of itself. It's working faster than it should, and it's causing issues between the concurrent connections between the two. So concurrency control standards is the answer. Question 10. A modern CI/CD pipeline leverages infrastructure as code, or IAC, to provision cloud environments. To ensure security is embedded into these automated deployments, which of the following is the most effective secure deployment practice? Or I should say development practice. Again, question 10 is a modern CI/CD pipeline, which is your continuous integration, continuous delivery pipelines. They will leverage infrastructure as code. So again, that's what is happening here. It's provisioning to a cloud environment, and you want to ensure the security is embedded in this automated deployments. Which of the following is the most effective secure deployment practices? A. Manual security review of the deployed infrastructure after provisioning. B. Running static analysis security testing tools, or SAST tools, against the IAC, or infrastructure as a code, templates. B. Implementing dynamic application security testing against running applications. Or D. Relying solely on cloud providers' built-in security features. So we're trying to evaluate this infrastructure as code. And what is the most effective way of looking at automated deployments? We talked about this a few times back on CISSP Cyber Training, and you would want to use a static analysis security testing, or SAST tool, against the templates themselves. Again, your dynamic aspects of it is when it's being already deployed. You're just trying to understand, are there issues in it right now? So the most effective way to secure the development practice is SAST, because it usually happens before you even think about doing DAST. And so you'd look at all of your text files and your templates, just like an application code. You'd want to make sure they don't have any vulnerabilities. And these SAST tools will analyze these templates before they actually deploy. So it's an important part of that. Question 11. When designing RESTful APIs, an architect specifies that all client requests must include a unique, short-lived token generated by a trusted identity provider used only for authentication. There's a good architect. Good job. This design choice primarily helps mitigate which API-specific security concern. Now, if you listen to CISSP Cyber Training, you know I love APIs. APIs are amazing, but they can be fraught with danger. So, the RESTful API that architect specifies all client requests must include a unique short-lived token generated by a trusted identity provider. That's a good thing. So the design choice primarily helps to mitigate which security concern? A, insecure direct object references, which we've talked about, and you know that's not it. B, excessive data exposure. C, resource exhaustion, or D, replay attacks. So the answer is D, right? A short-lived token that is used only once, right? A very short expiration date is typically referred to as a nonce, N-O-N-C-E. Unless you're in the banking industry, you have a tranche, and a tranche is a French trench. No, it's not. I'm joking, but I still love that. It's so cool, a tranche. No, a nonce is a token with limited validity. Basically, it doesn't last very long. That's the ultimate point. And this helps mitigate the replay attack, right? So someone intercepts a token, it's single use, they try to use the API, and because that token is single use, they got nowhere. They're dead. Nothing happening. So again, that's what would help avoid a replay attack. Question 12, a security requirement states that critical applications code must undergo independent peer review by a security-trained developers before going to deployment. That's good. Very good statement. This practice primarily addresses security weaknesses related to what? Again, a security requirement, which you all should be working to build, critical application code must undergo independent peer review by a security-trained developers before deployment. What practice primarily addresses this security weakness? A, lack of automated security tools. B, inadequate vulnerability disclosure process. C, logic flaws and complex coding errors. Or D, insufficient threat intelligence integration. Okay, so this practice addresses what concern or what security weaknesses? Logic flaws and complex coding errors. Again, having another set of eyes that is not part of the process will help find some of these issues. They don't find them all, but that if you are in the development space and you've been working on some sort of project, you kind of go blind to where some of the areas are at. Give it to an independent third party and they can look at your security and they can look at how it's coded and therefore give you options on what to do. Question 3, in a software-defined security environment, or SDS, where security policies are managed as code in a Git repository, which of the following is the most critical secure development practice to prevent unauthorized or malicious policy changes from being deployed? So again, you got people that are using Git, and you're basically utilizing secure development practices. What do you want to do to help keep that from happening? So, what do? A, implement a strict rate limiting on API calls to the SDS controller. Okay, so you're limiting what APIs can go to it. B, mandating multi-factor authentication for user login to the application. Well, APIs don't always use some sort of multi-factor. C, enforcing pull request reviews and approval workflows before merging policy code. Okay, that has merit. And then D, regularly scanning deployed cloud resources for misconfigurations. Okay, the most critical secure development practice would be C. Now, when you're dealing with pull requests, so it's enforcing pull requests, reviews, and approval workflows before merging any policy code. What does that specifically mean? Well, you have stuff that's in Git, and you're going to merge these different branches together. Well, before they can be merged together, and maybe you're using API to do this, you want to make sure that there's an approval process saying, okay, it's automated, but before it happens, I've got to mash on the button saying, I agree. So there's a lot of benefit of doing that. Now, the downside, obviously, is it adds time and it adds complexity and bureaucracy. So you need to really consider how you want to go forward with it. I think it's a great idea from a coding standpoint, and it does allow oversight into what you're doing, especially when some of these things you're dealing with critical infrastructure like chemicals where it'll eat your face off, or you're dealing with financial industry where they have all your money. So those are just things you want to consider. Question 14, a financial application processes customer requests concurrently. A vulnerability is identified where, due to imprecise timing of multiple threads, we've heard this before, accessing a shared variable, the customer's account balance could be incorrectly updated. Oh, that would be bad, especially if it goes to the good. You'd think that would be good, but then when they start clawing back their money, that's not good. This scenario describes a classic time of check to time of use vulnerability, or TOC/TOU. B, a broken authentication. C, server-side request forgery, or D, XML External Entity attack, or XXE. So again, the process is it looks like you have some timing issues. So if you got timing issues, what could that be? Well, I don't know anything else that's on this page. So, time to check and time to use. Let's go with that. That would be the logical point if you do not actually know what any of these mean. So what it comes down to is this is an example of time to check, time to use vulnerability, which basically is a specific race condition and occurs when the system checks for the state of the resource, which we kind of talked about earlier. Based on that, it performs an action, which is your time of use. But if the state of the resource changes between the check and the use, this could have an imbalance and this could cause issues. So you want to try to avoid that at all costs, especially if there's a vulnerability around that. Question 15, the last melon. When designing API endpoints that handle sensitive customer data, what is the most critical secure coding guideline to follow regarding the data returned in API responses? Again, when designing API endpoints that handle sensitive customer data, important, what is the most critical secure coding guideline to follow regarding the data returned in the API responses? A, always return all variable data for convenience as long as it's encrypted. Convenience always gets you. B, ensure all sensitive fields are masked or redacted by default, returning only the necessary information. That sounds positive. B, rely on client-side, C, rely on client-side filtering to display only relevant data to the user. Okay, that could be, but it's still out there and it's still available. C or D, implement strict rate limiting on API responses to prevent data exfiltration. The answer is B, ensuring all sensitive data fields are marked, are masked, or redacted by default. Again, only providing the information necessary for the request. And again, this aligns with the principle of excessive data exposure, which is part of OWASP's top 10 API security risks. You want to understand all of those before you're going out and going forward. APIs, again, they're awesome, but they do have some challenges. Okay, that is all I have for you today at CISSP Cyber Training. Head on over to CISSP, get some free content. You'll love it. Check out what some of the people have said on the podcast. If you listen to the podcast, please leave a review. Let me know. Is it good, bad, ugly? What do you think? I got a lot of positive. I've also got a couple negative, which is great. I think that I appreciate the negative to give me some more feedback on some things that we can change for you. Man, we've made some changes based on that feedback. But go to CISSP Cyber Training and get access to all my free content. There's a lot of it out there. Also, go get access to my paid content. There's even more of it out there. And all of that is available to you to help you pass the CISSP exam. What do we say? The first time. If not, that's okay. We're here for the second and third if you need to. But let us focus on the first time. All right, again, thanks for everything, and thank you so much for listening to us podcast, and we will catch you all on the flip side. See ya. Thanks so much for joining me today on my podcast. If you like what you heard, please leave a review on iTunes, as I would greatly appreciate your feedback. Also, check out my videos that are on YouTube, and just head to my channel at CISSP Cyber Training, and you will find a plethora or a cornucopia of content to help you pass the CISSP exam the first time. Lastly, head to CISSP Cyber Training and sign up for 360 free CISSP questions to help you in your CISSP journey. Thanks again for listening. Hey, thanks again for listening today. It's been my pleasure to prep you for the CISSP exam. Are you interested, though, in some free CISSP exam questions? Head on over to freecisspquestions.com and sign up to join my email list, and you'll receive access for 60 free CISSP questions each and every month for the next 6 months. That's a total of 360 questions just for signing up with CISSP Cyber Training. You'll also gain access to other free CISSP resources, so just head on over to freecisspquestions.com and sign up, or head on over to CISSPcybertraining.com and sign up today. Have a wonderful day, and we will catch you on the flip side. See ya.